slope of a tangent line. And to get the slope of a tangent line, we used a bunch of secant lines, right, as they were approaching that value. So we could see the changes in the slopes and tell what they were approaching. This also applies if we are looking at velocities. So for example, suppose a ball is hit straight up from the ground with an initial velocity of 80 feet per second. Find the velocity of the ball after 4 seconds. We are using this vertical motion formula. This is one we will see periodically throughout the year. S is just representing height at a given point in time. So that's negative 16t squared plus v sub 0. What do you think that means? Velocity at 0 seconds. So our beginning velocity, which was 80 t, plus what do you think h sub 0 means? The height at 0 seconds. If we started on the ground, what was our beginning height? 0. So that's my height equation. Okay, I want the velocity. So velocity is a rate of change. It's like the speed. So a rate of change, that's like a slope. So we need to estimate the slope at 4 seconds. If my time is 4, can we figure out what the height is at that point? We plug a 4 in here, so it'd be negative 256 plus 320, so 64. All right. So to get our velocity, we are going to make a table just like yesterday. At a given point in time.
How did you get 64?
Oh, I put 4 in here, so maybe 16 times 4.
Oh, okay. I was thinking the 16 would be positive.
Oh,
yeah, I get it.
Gotcha. It's just the 4 that's squared. Okay, so we're going to get a time, get our height, and then to get our velocity, we'll have to do the slope between those 2 points to get our rate of change. Is it enough to only go from one direction? No, we talked about that yesterday. All right, so we are going to divvy up the work here. We need to be approaching 4. So if I did numbers smaller than 4, that might be like a 3.9, 3.99, 3.999. If I did numbers bigger than 4, so maybe 4.1, 4.01, and 4.001. So Sam, I want you to do 3.9. I want you to plug it in to get the height, and then also do the slope between the 464 and that point. Hunter, you have 3.99. I want both of you to do 3.999. Well, actually, no, we do have just 6 people. Okay. Tanner, you get 3.999. Bryson, you get 4.1. Cole, 4.01. Toby, 4.001. So get the height and the slope. 9. What did you get for your height when you plugged that in?
16.4.
Okay, and then your slope? Okay. For the 3.99, what did you get for your height?
64.478.
And what did you get for your slope?
Negative 47.84.
All right, and 3.999. Tanner, what did you get for your height?
64.047984.
And what did you get for your slope?
0.047996.
Let's double check that one. I think your slope might be off. So you're doing the 64.047984 minus 64 over 3.999 minus 4. Maybe misprint or something. What'd you get this time?
Negative 47.94.
Okay. What does it look like these might be approaching? Negative 48. All right, 4.1. Bryson, what'd you get for your height?
59.04.
And your slope?
I messed that up.
Okay, so let's all do it. Y2, so 59.04 minus Y1, so minus 64. So you're doing this Y minus that Y over 4.1 minus 4. All right, what'd you guys get?
Negative 49.3.
4.01, what'd you get?
63.5184.
And your slope?
Negative 48.16.
All right, 4.001, what's your height?
63.951984. And my slope was negative 48.016.
And so what's that approaching?
Negative 48.
All right, so we have to look. What if both of these tables went to something different? Would we be able to tell what our overall slope was? No. Would they have to be the same? These are, why would velocity be negative?
It's going backwards.
It's going down. Velocity is speed with direction. Okay, so a negative tells us it's going down, a positive tells us it's going up. Our units, that is feet per second, it's like a slope. So it's falling 48 feet per second after 4 seconds at that one particular point in time. If I did it at 3 seconds, do you think my velocity would be different? Yeah, every time would have a different velocity. All right. Any questions there? So what we just calculated is called an instantaneous velocity. It's a velocity at a specific point in time. So I wanted the velocity after 4 seconds. So if I did the velocity after 3 seconds, at one particular point in time, that's our velocity. Let's say it's probably, if you try to log in the whole thing, make sure you do parentheses. That's the biggest issue with those calculators. So that instantaneous velocity at one particular point in time, that's like our tangent line. So the slope of the tangent line is instantaneous velocity. The slope of a secant line, so slope in between 2 points, that's the average velocity. We were trying to estimate the velocity at 4 seconds. So we used the velocity between 2 other points. We used an average velocity to approximate it. So let's look at a problem involving average and instantaneous velocities. A rock is thrown upward with a velocity of 20 meters per second. Its height in meters t seconds later is given by this equation. So here's our height formula. I want the average velocity during each time period. So what I gave you here, these aren't ordered pairs, this is an interval, so it's saying when t equals 1 and t equals 1.5. I want the average velocity from those 2 points. So if I were going to do that, we would have to get ordered pairs. So if I plug in a 1 and a 1.5 to my equation. So if I put in a 1, I get 20 minus 16, which is 4. If I put in a 1.5, we get negative 6. So the average velocity is just the slope between those. Negative 6 minus 4 over 1.5 minus 1. We get a negative 20 meters per second. So between 1 and 1.5 seconds, it fell 20 meters per second. Okay, if I wanted between 1 and 1.1, so I know 1, 4 is a point. If x is 1.1, so we have to plug 1.1 into our formula for the t. 13.64. So now we do slope. Y2 minus y1 over x2 minus x1. And we get negative 13.6 meters per second. Do you guys know how I'm getting these? Okay, why don't you try the next two? So, did you guys get negative 12.16 for part C and negative 12.016 for part D? So what we did there, we were finding average velocities. There, we just found the slope between 2 points. That's all an average velocity is. The instantaneous, part B, is what those approach. You notice we use the 0.14 for all of them. Okay, so that was like the point we're approaching. And then if I look at my other x's, they were getting closer to 1.5, 1.1, 1.01, 1.001. So instantaneous velocity is asking you, what are these velocities approaching? What would you call that? Negative 12 meters per second. Now, is this an exact science? No. Is it possible that it's approaching negative 12.01? Yeah. We're giving it our best guess here, so we should be pretty close to being accurate. All right. These problems are long, but the calculations aren't hard. It's plugging something into an equation to get a y and then a slope. So it's a calculation you've done before. We're just doing it over and over and over again with uglier numbers. Are there any questions? We have quite a bit of time now, so you need to finish that handout. It's due tomorrow. You have the rest of the hour to work on it, check it,